Good morning, everyone. Today is our first lesson of week 5, and we're going to be talking about percent rate of change. So our objective is to compute values of percent rate of change functions. All right. First things first, let's do the do now. So take a second, pause this video, and rewrite the following percentages as decimals. All right, so hopefully you've done this. In order to convert a percentage to a decimal, we always have to divide that percentage by 100, right? Because this is 87% out of 100 is the largest. So we get 0.87, 60 divided by 100 is 0.6, 3 divided by 100 is 0.03, and 7.5 divided by 100 is 0.075. Okay, so make sure you have those zeros here and here as the placeholders for 3% and 7.5%. Because otherwise, if we had 0.3, that would be 30%, right? Okay, so first, what I want to do is recall and remember our old exponential change formula. So this is exponential growth formula or decay. So we have f of x equals a times b to the x. This formula is still going to be relevant because our new formula is very similar. So remember, a is going to be our y-intercept, which is usually an initial value or a starting point, right? Anytime we think y-intercept, we think start. So that's where something starts, okay? And then b was our rate of growth or decay. And if you remember, if b is greater than 1, that's growth, and if b is less than 1, then our function represents a decay function, right? And then we have our function and our input value of x. Okay, so now we're going to use this percent rate of change formula, which is very similar because you've got p times 1 plus r to the t, okay? So similarly, p is going to be our initial value. Initial value, or the starting amount of money that we deposit into a bank, something like that, okay? Then my r is my rate. But what we're going to do, just like we did in the do now, anytime we have a percent, we're going to convert percentages to decimals to get a rate, okay? So the rate is always going to be the decimal form of this percentage. So then 1 plus a rate, if our rate is positive, we'll have growth, and if our rate is negative, then we'll have decay, right? Because 1 minus some kind of rate would be a number less than 1. Okay, now t, our input value is just going to be time. So our time could be hours, months, years, whatever. So let's go ahead and do an example so you can kind of see what I'm talking about. So example number 1, the interest on a credit card payment is about 20% per month. Suppose Mary does not pay off her credit card bill of $350. Write a formula to model the amount of money she will owe each month if she does not pay off her credit card. How much money will she owe after 5 months? Okay, so what are they asking us to do? First, we need to write a formula. Then we're going to need to figure out how much money will she owe after 5 months. All right, so let's start with writing the formula. We know our formula is going to be in this basic form, right? F equals P times 1 plus R to the T. So I need to fill in whatever I can, right? So P is an initial value. Do I have an initial value? Yes. I'm going to circle this. $350 is my initial value. So I know that's my initial value because that's how much debt she started with. So she had a bill of $350. That's at the start. In 5 months, it's going to be different. So I'm saying my starting value is $350 times 1 plus, now R represents rate. So do I have a rate here? Yeah, I'm going to look for that percentage. So when I see a percentage, I know that's going to be my rate, but I'm going to have to convert it to a decimal by dividing by 100. So 20 divided by 100 is 0.2. So that's what I'm going to substitute in for R. So my formula, if I simplify, will be 350 times 1.2 to the t, because I added 0.2. Okay, so now I've got a formula, which is part 1. Now I need to figure out how much money will Mary owe after 5 months. So if 5 months, that's going to be an amount of time. So time is t. So I'm going to say, okay, 5 months is my t value. So I'm going to substitute in 350, 1.2. I'm substituting 5 into my t value. Okay? And since this is months and my rate is months, we're all good with units. Everything's the same. And now I can pop this in my calculator. So since I'm using my phone calculator, I'm going to put 1.2 to the 5th first. Okay? So then I have F equals 350 times 2.48832. And then I'm going to multiply this by 350, and I'll get F equals 870.912. But since this is a dollar amount, right, we know this is how much money she owes, my real answer would be 870.91. That would be dollars, would be the correct units to use here. Okay? So, and this is real, right? So if you don't pay off your credit card bill, you could owe a lot more than you initially borrowed from the credit card. So whenever you get a credit card, be careful. Always pay your credit card off as soon as you can, right? All right. Ready for the next one? If not, you can pause the video, go back, rewatch that example. But I'm going to be doing example number 2 now, which is a little different. The value of a car decreases by about 15% per year. Suppose Daryl buys a new car worth $30,000. Write a formula to model the worth of the car after each year. How much is the car worth after 5 years? Okay, so same thing. Let's see what they want us to do. They want us to write a formula and then figure out how much is the car worth after 5 years. Okay, so to write my formula, I'm going to circle my numbers. I have 15% and I have 30,000. Now, what's interesting here, it says the value of a car decreases. Okay, so this is important. We have to figure out each time if the rate of change is increasing or decreasing. So, let's start with my P value. I know my initial value. The car is worth $30,000. But my rate, if my rate is decreasing 15% per year, I'm going to write 15%. But since it's decreasing, that's going to be a minus 15%. So, and I do negative 15 divided by 100, I get negative 0.15. And then, when I substitute this into my formula, F equals 30,000 times 1 plus negative 0.15 to the t. Okay? So if I'm adding 1 plus negative 0.15, that's like I'm doing 1 minus 0.15. So really, my formula will be 30,000 times 0.85 to the t, right? So we have a b value of less than 1. So this represents an exponential decay problem, okay? Because the value of the car is decreasing. So now let's find out how much is the car worth after 5 years. So I'm plugging in or substituting what number for my time? I'm going to find 5. 5 is my time. So F equals 30,000 times 0.85 to the 5th. And I'm going to go to my calculator because I don't know what 0.85 to the 5th is. Oops. So I need to do 0.85 to the 5th power, which is 0.44 So I'm going to write this over here. F equals 30,000 times 0.44. And I'm going to multiply this value times 30,000. Okay, so my final answer will be, and if I use correct units, $13,311, and if I round correctly, 16 cents. So after 5 years, that $30,000 car was only worth $13,000. So that's a real thing too, right? When you buy a car value only goes down because you put miles on it, it gets wear and tear. It might even be less than that, depending on the car. Okay, let's do 2 more examples. If you think you've got it, you don't need to stick around. You can go ahead and try the classwork, but if you want to do some more examples, we're going to do some more. Example number 3. A bank is offering its customers 4.2% interest per year on savings accounts. If a customer deposits $2,000 in the account, how much money will a customer's account be worth after 4 years, or what amount? Okay, so we want to figure out the worth after 4 years, and we know there's 4.2 interest per year, and the initial deposit is $2,000. So I'm going to write my formula first, even though they don't say write a formula. You still need a formula. So F is going to be initial value times 1 plus the rate. 4.2%, 4.2 divided by 100 would be 0.042. All to the T. My T value is going to be 4 years. F equals 2001.042 to the 4th. And I gotta do this in my calculator, right? Because I don't know. So I'm going to say 1.042 to the 4th is, so I have $2,000 times 1.178. And my final value will be $2,357.77. Okay? So this problem, anytime we're talking about interest, that's going to be growth. So I knew this was going to be plus 4% or 4.2% because interest is always growth. And then I used my initial value of $2,000 and multiplied that by 1 plus the rate to the T. My T value was 4 years because it's interest per year, so my years and years are good. And in the end, this savings account is worth $2,357. So that's pretty good for a savings account to earn that much interest. All right, one more example just to make sure we've got the understanding, because this one is going to be interpreting a little differently. So the following formula models how much money a customer will have each year from a savings account. M equals 450 times 1.3 to the T, or 1.03 to the T. How much money did the customer initially deposit into the savings account? Okay, so initial deposit, that's got to be my P value, right? So I'm looking, what's in my P spot? And I know my formula is F equals P times 1 plus R to the T. So in the spot where the P is, I see 450, and this is dollars. So the initial deposit should be $450. All right. What is the percent rate of change for this account? And what does that mean? So percent rate of change, R is just the rate. Percent rate of change means we need it in the percent. So if R is my rate, and I know 1.3 or 1.03 is in the spot where it's 1 plus R. So 1.03 equals 1 plus R. That means, if I subtract 1 from each side, my R value we should have r equals 0.3. So if r equals 0.3, we know that 0.03, excuse me, I keep forgetting that 0, which is an issue. So if r is 0.03, that's the decimal version. I know that when I have a percent, I divide by 100. So in order to get from a decimal back to a percent, I need to multiply by 100. So my percent will be 3%. Then what does that mean? That means in this scenario, this person initially deposited $450, and this customer earns, so they're increasing, 3% interest. And I want to look at my units each year. From the money in this savings account. Okay, so this is an example of where you're interpreting what these things mean. Okay, so you're going to see all these kinds of problems in your Google form. And if you don't get a perfect score, I would take it again so that you can try the problems again and see what you did wrong. And if you have any questions, please feel free to reach out to me or come to office hours. All right, talk to you all later.